In this video, I want to go through a CFA Level 1 question on the topic of kurtosis, yet another parameter which describes the properties or the shape of a distribution, something you absolutely need to know about and be ready to answer questions on. So if this is something you want to get right in the exam, keep watching and let's get solving. So this is our question. Compared to the normal distribution, a distribution described as leptokurtic has a smaller percentage of small deviations from the mean, a greater percentage of small deviations from the mean, or perhaps thinner tails. Okay, because the question asks with normal distribution, I'm going to tell you that the normal distribution, which you should know is symmetrical, that's something I said in a previous question, is going to be asymmetrical, just like I said. So it will have no skew. Skew equals 0. But another absolutely essential and vital property of it is that it has a kurtosis of 3, which we describe as being mesokurtic, something you need to appreciate. Now, what is this thing called kurtosis? This is a measure of how peaked the distribution is. So, difficult word here for me. It's a measure of peakedness. Okay. And when I say that something is peaked in a more or less, and that's what kurtosis measures, what we're basically alluding to is this, the level to which the distribution is either extended or more sort of flattened out. And, mesokurtic, and this is measured by the parameter called kurtosis. And it just so happens that the normal distribution has a kurtosis of 3 and it's symmetrical. And that's what makes it actually normal. Now, in your books, there is a formula for kurtosis and how to calculate it. I'm not going to show you this one because it's not part of the question. And anyway, I don't think there's a very high probability that it will be asked in the exam, that you'll be asked to actually calculate this. I think it's more likely that you'll be asked to interpret kurtosis and kind of draw conclusions from its value. Now, one more thing is that the normal distribution has no excess kurtosis. Excess kurtosis equal to 0 because excess kurtosis is whatever the kurtosis of a specific distribution is minus 3, which is the level for the normal distribution over here. So if we're dealing with a normal distribution, it would be described as having no excess kurtosis. Hopefully that makes sense. Now, you need to not just appreciate that the normal distribution is described as mesokurtic, you'll also need to know what a leptokurtic and platykurtic distribution is. So I'm going to do my best to draw this as well as I can. Okay. And let me start with something that will, I guess, more or less, hopefully, approximate the normal distribution. So here it goes. Not perfect, not exactly symmetrical, but, I gave it my best shot. So this is going to be my normal distribution. So one which has a kurtosis of 3. It's obviously symmetrical. Even if it doesn't look precisely symmetrical here. And in terms of excess kurtosis, that's 0. Now, a leptokurtic distribution, which we're being asked about here, is going to look like this. It's going to have essentially fatter tails. But then in the middle, it's going to be definitely more peaked. Okay, quite happy with this one. So this is a leptokurtic distribution. And it will have a kurtosis parameter, because it's more peaked, which is higher than 3. And it will absolutely have positive excess kurtosis. because kurtosis is higher than 3, then whatever it is minus 3 is going to be more than 0. Okay, good. And finally, one more, even though you're not asked about for this one in the question, I'm going to show you anyway, and that's called the platykurtic distribution. And the platykurtic is going to be flatter, and it's going to have thinner tails. So it will look something like this. Okay, that's not too bad here. So this is a platykurtic distribution. And it's going to have a kurtosis which is less than 3 because it's less peaked. And its excess kurtosis is actually going to be less than less than 0. It's got negative excess kurtosis. Good. So what's going to be true here for the normal distribution or the leptokurtic distribution versus normal? It is going to have, the lepto is going to have fatter tails compared to the normal. So this green versus the pinkish color, you can see that there's more observations in the extreme values, so in the tails. And that's going to be a higher proportion of extreme values, which are further away from the center, from the mean. So the first suggestion here, that the leptokurtic has a smaller percentage of small deviations from the mean, and then suggestion B, a greater percentage of small deviations from the mean. They obviously are contrary to each other. C, thinner tails. Well, I can eliminate C straight away. What about the small deviations from the mean? Well, you can see in the middle here, where we have small deviations from the center, there is more volume in the green distribution, the leptokurtic one, meaning there is a greater percentage of small deviations from the mean relative to what the normal distribution would show us, not a smaller percentage of small deviations from the mean. So this is absolutely 100% in line with answer B.